Sir Isaac Newton was one of the two greatest physicists who ever lived, and much of what we know about the natural world comes from what Newton taught us. In fact, his 3 laws of motion are so well known that they're simply referred to as the first, second, and third law of motion. This tablecloth trick is a great application of Newton's first and second law. Newton's first law can be summed up in one word, and that's called inertia. And it simply means that an object at rest stays at rest until acted upon by an unbalanced force, and an object in motion continues in motion in a straight line at a constant velocity until acted upon by an unbalanced force. The key to this is that the more massive an object, in other words, the heavier an object, the more inertia it has, the more resistance it has to change in motion. In the plates and cup, you have some objects that have a substantial amount of mass, therefore have a substantial amount of inertia. His second law, F equals ma, simply means that if you apply a force to an object, it will cause that object to accelerate. In this trick, we are applying a force to the tablecloth. We are accelerating the tablecloth, but the force is never applied to the plates. They, because of inertia, will tend to stay in place, while that force applied to the tablecloth makes only the tablecloth move. Well, let's try this out. See if Newton was right. 1. 2. Newton strikes again. Let's try an instant replay of that. Tonight when you go home, this is something you can try. Don't use your good china, but taking some china from home, maybe some silverware, set yourself up a plate setting. In fact, this is a great way to clear the dinner table after dinner. Let's see, we'll have a plate and maybe a salad plate or a saucer, some silverware, and a cup or a glass. Okay. When I did that the last time, you notice that one thing did move. The spoon and the fork actually did move. And think about how that applies to inertia. Again, the plates are very massive compared to the spoon. So they have a lot more inertia, a lot more resistance to change in motion than the spoon and fork did. These are fairly light. They have a small amount of inertia, and so the small amount of friction that was applied by the tablecloth was actually enough force to make those move. In applying the tablecloth, you need to get a cloth or a tablecloth that has one edge that has no hem on it. That straight edge is vital because if you have a hem pulling under that lip of the plate, that will actually apply enough force that will be an unbalanced force, and it will cause the plate to move. The other part is, again, your acceleration. Remember Newton's second law. You're applying a force only to the tablecloth, not to the plates. So when you pull, you need to pull straight down with a lot of acceleration. Straight down, real fast. I'll show you, if you pull out, you can see those plates moving. That's because in pulling in that way, you're applying enough force of friction to get those plates to move. We don't want that. Okay, get your tablecloth straightened out. Real nice, no bumps in it that will apply friction. Now we're going to try accelerating straight down, real fast. Newton was right.